I want to welcome you again to this YouTube channel and to this Pandas documentation series that we've been exploring. Today we want to ask ourselves this question: how do I create plots in Pandas? And so you might be, of course, you wonder, there's no analysis without visualizations, right? So how do we create plots in Pandas? And this is the question we want to answer. And so for that, we'll continue from where we left off. The data set we'll use today is this data set, which is air quality data. And it's about NO2. This data set provides NO2 values for the measurement stations FR04014, BETR801, and London Westminster in respectively Paris, Antwerp, and London. Now I'm going to leave a link to data set in the description. So if you click on that link, it will take you here. Now once you are here, what you want to do is to look for this button that says download raw file. If you click download raw file, it's going to download to your system. And once you've done that, we can then continue together from here. So I'm going to create a new file. I'm going to a new notebook in Drive, just as we've been doing. I will rename it to create plots in Pandas. Once I'm done with that, I will expand this file. Once I expand that file, I want to mount the drive so that I can have access to Google Drive. Connect to Google Drive. I'll wait for it to mount. Once it's mounted, I'll see the drive here. All right, so it's mounted. We have this drive. I will just drop down to where I have my data sets stored. In my case, I have my data set stored in Pandas documentation. I have my data set stored here. So I will upload that file here. Upload to data air quality. Ensure your files are saved somewhere, no problem. Okay. So now I have the data set here. This is it, air quality. So we can now continue with our work here. Now we are doing two things. One, we'll use Pandas, right? But it's not just Pandas alone that we'll be using. For the visualization aspect of things, we'll use the Matplotlib. And so to begin, I'll have to import those two libraries. The first one is import pandas as PD. That enables us to use Pandas. In the next one, let me close this. The next one we want to import here would be matplotlib.pyplot as PLT. Again, by convention, this is given an alias of PLT. Now I'm done with that. What do I want to do? I would want to read in the data set that we just uploaded now. And to do that, again, if you haven't forgotten, you navigate to the data set. You click on these three arrows here and you copy path. Once you do that, we come back here. I can close this again. We come back here and we want to call this data frame air quality. And we say pd.read_csv. We pass in that path that we just copied now. Now there are other arguments I would like to supply here, because the first one is the index call. And what I want to use the index call to do is to specify that I want the first column, in this case, I'm going to say 0, because what I want is that the first column should be the index of the resulting data frame. And so think of it like this. If you have a data set where you have unique values. So think of if you're working on student data, you have something like a student ID or student matric number. If you're working with employee data, you have something like an employee ID. Those are unique, right? Those are columns that you might turn into the index of your data set. So, and that's just what we're specifying here, that we want the 0th, that's the first column, of course, with the index 0. We want the first column to be the index of the resulting data frame. The other thing we want to do is, because this index is date object, we want to convert the date into timestamp objects. And so for us to do that, we would just say parse dates. That's what we'll use, parse dates, and we want to set that to true, just so that it parses the date into timestamp object. And I think those are the two new things that you probably have seen so far while we're using this, working with Pandas. So I run that cell, and this is what I have here. So how do we, let's say now, I want a quick visual check of the data. How do we do this? Now, for us to get a quick visual check of the data, one thing we can do is to say air quality dot plot. And we run that cell, and we have this, as you can see. Right? Now, with a data frame, Pandas creates by default one line plot for each of the columns with numeric data. Let's say further, I want to plot only the columns of the data table with the data from Paris. Now, what does this tell you now? As you can see, again, we have this. We are specifying that we want only the data from Paris, right? And we want to plot only the columns of the data table with the data from Paris. So we don't want anything else apart from that. Now, how do we get the data from Paris? So in order to do that, let's quickly look at what we have here. Air quality dot head will quickly give us what the data set looks like. As you can see, this here is the air quality of the Paris station, right? And so that's what we're looking at here. That's what we want to plot. Only this column, right? Now, if you've not forgotten, how do we select only one column? Can you still remember? Air quality, then with the square bracket, and we select that, we type in the particular column, and that's it. So if you run this, in fact, we should have just that column. And again, don't forget, what is this? Is this a data frame or is it a series? Again, this is just a single column, even though you have this here. Now, this serves now as the indices. Remember, I told you that indices that got created automatically for you, it's no longer there now because we've specified by saying that we want the index call here to be 0. And so this becomes the index. And I don't want this to confuse you, right? So let's say we want to know what type is this. Is it Pandas? Is it data frame? Is it series? If we run that, as you can see, this is indeed series. So don't get confused by the second value you see there. This is the indices. This is the index part of the the series. All right, so if we want to plot, all we just need to do is just to pass that dot plot again, and when we run this, as you can see, we have this nice plot for us. And so to select, to plot a specific column, we use the selection method. Remember the previous video where we talked about how to select subset of a data frame. Now we take that, what we learned in the previous video, and when we combine it with this plot method, so we get what we have here. Now plot method works on both series and on data frame. Now let's even take this further. Let's say I want to visually compare the NO2 values measured in London versus Paris. Now you can see that we have two different things now. We are talking about London, we're also talking about Paris, right? Now, but that doesn't mean that we have to select anything in this case, because we want to compare these values. We want to compare two values. We can use a scatterplot. And to do that, we can say air quality, air quality dot plot dot scatter, right? And then we pass in what we want to look at. The X is station London, which we have here. And in fact, I can just copy it here, and we want to look at station Paris. I'll copy that, station Paris, and I'll make it into the Y here, equal to station Paris. So I can plot this. I have this. Now you can see how thick this is, right? How dark this blue color is. Now, if I want to make it a little bit faint, or, you know, kind of like faded into the background, I can use another argument here, which is alpha. So I can say alpha equal to 0.7, for instance. So if I run this, you can see how that looks now. So again, if I say alpha equal to 0.5, let's see what we get. You see it's even more faded now. Now, apart from the default line plot, when using the plot function, we have a number of alternatives that are available to plot data. And let's use some standard Python to get an overview of the available plot methods. And for us to do that, let's do this. Method name. For method name in air quality dot plot, if not method name that starts with underscore. If we run this, let's see what we get. And so these are all the kinds of plots that are available, and that's simply what this does for us. And in many development environments, as well as IPython and Jupyter Notebook, you can always use the tab button to get an overview of the available methods. So for instance, while we were trying to look at this air quality dot plot dot whatever, we can also do something like this, where we say air quality dot plot dot, And once I hit that dot, we can use we can wait for the IntelliSense in this case, but in other cases, you can always use the tab. So for instance, I can select what I want to select. So if it's pi, once I select it, I can use the tab button to pick that actual plot. Now, one of the options that we have is the box plot. And as you see here, this is box, right? And this method is also applicable on the air quality example data. And so if we, for instance, say we want to plot the box, we want to use the box plot rather, we can do air quality dot plot dot box. And this is going to give us the box plot as you see here. So we have the box plot shown to us. Now, so let's now say that I want each of the columns in a separate subplot. Now, we want each column in a separate subplot. Now, separate subplot for each of the data columns are supported by the subplot argument of the plot function. And so there's an argument which allows you to use this to do subplots. And I'll just do that now. So you see AXS equal to air quality dot plot dot area. I'll set the fig size equal to parenthesis 12,4, then subplots equal to true. And so what this does is that it allows us to create different plots, that's subplots for each of the data. And so if we run this, let's see what we have. As you can see, this is plot for station Antwerp, for station Paris, for station London. So rather than have everything in one plot, we can have subplots for each of these stations. Now, the built-in option available in each of the Pandas functions, they are worth reviewing, and I encourage you to review those. But let's say I want to further customize, extend, or save the resulting plot. How do we do that? Can we indeed save a plot we have here and maybe use it, maybe print it out or something like that? Definitely we can. And so let's see how to do this. We have fig, AXS equal to plt.subplot. Subplot, we have the fig size equal to 12,4. And sorry, I wrote, that should be PLT, which is the alias we have here, right? In case you're wondering where we got PLT from. That's this alias we have here when we were importing Matplotlib pyplot. This PLT is what we have here. So we are calling the subplot function, which we can pass in some arguments like the fig size, 12,4. I'll run that cell. And as you can see, we don't have anything, right? There's nothing. So this just creates a template for us where we would then put all our plots. And we'll see how this works as we go along. So let's say air quality dot plot dot area AX equal to AXS. And by the way, AX is just the axis, right? And I'll run that again. It just tells me that the axis, the X label is date time. Okay. And then I want to also set the AXS dot set y label. I want to set the y label to no underscore 2 concentration, and this is NO, which is uppercase O. Okay, so I have this, I get this result. The next thing is to do fig.save fig, and I want to save that. So let me create right here. I'll create a folder which I will call images. So I'll create that new folder now. I'll call it images. I'll copy the path of that folder I just created. Copy path. I'll put that path right here. And I'll do a slash no2 concentration.png. And so if this part of the code works well, I should see an image here. As you can see at this moment, the image isn't showing here, right? But once I run this cell, I should get an image here if that cell runs without any error. And so we have this, as you can see, we have that image right here, stored for us in a PNG format. All right, so now let's see what the image looks like. I'm going to, I just double clicked the image and we have this. And so the image is now saved for us, and we can use that image. We can export the image, we can download the image, we can print it out if we want to use it. But again, you can see the essence of customizing. This is the date time, but this NO2 concentration is what you see here. The NO underscore 2 is more like saying that give me a subscript. In this case, give me a subscript and make 2 subscript. So let me show you that again. Look at this. You can see the 2 is a subscript, right? So that's what this part here does. All right. Each of the plot objects created by Pandas is a Matplotlib object. As Matplotlib object provides plenty of options to customize plots, it makes the link between Pandas and Matplotlib explicit. So what we did earlier, we can also write it all together. So like saying fig, and just so I don't take much time rewriting this, because again, what I just want to show you here is that we can have all of this, all that chunk of code, we can have them all in one place. And you probably see this more often than what I just did here. This, and we have the Y label. We have the Y label here. Then we have the fig. So this time around, I'm going to call it another name so that you can see. And then finally, we can call plt.show. So this is typical of what you would see in many texts, and of course it's more intuitive because you don't want to break too much of lines of codes that should ordinarily be together. This is doing one thing, and so you can put them together in just one chunk, one cell. So I'm going to call this NO2 concentration 2. At the moment, keep an eye on this. You see, if I refresh it, we don't have anything. We only have that one image. But now I'm going to run this. I'm going to run this cell. And once I run that cell, now you can see it's even much better because I can see the output. Recall that when I did it here, I didn't see anything. And that's also one of the advantages. So if you run it here, especially using the Google Colab, you should always do this together. But again, even more than this is, I want you to look at this. I'm going to refresh it now, and we should see another one here. There we go. So as you can see, we now have two different ones. One is concentration 2, which is this one we have here. All right, so just a recap of what we've done so far. I'm going to close this. A recap of what we've done so far. The .plot.anything method. They are applicable to both series and data frames. By default, each of the column is plotted as a different element. So by default, you have each column plotted as a different element. It could be line, box plot, and the other plot we saw up there. Any plot created by Pandas is a Matplotlib object. And so with this, we've been able to look at how to create plots. And like I said, it goes beyond this. We can do some way more sophisticated stuff using this library. But again, we're just exploring the Pandas documentation. And thank you for your time. If you haven't subscribed up till now, kindly do so. And when you watch these videos, it helps to give it a thumb up, and you can also share these videos with others. I'll see you in the next one, where we talk about how to create new columns derived from existing columns. See you then. Bye.